Hello students. So today we are going to talk about a very important topic of before we start physics in class 11, that is the basic mathematical tools. As you can see here on the screen, we are going to talk about the basic mathematics which is required every now and then in our physics. So to begin with the basic mathematical tools, we need to concentrate on what are the topics that we have to focus on before we start studying physics in class 11. Right? It's not only of class 11, it's about your entire life through what you will study physics. Okay? So the topic that you have to concentrate on, we are going to discuss those topics. Number one, we'll talk about basic trigonometry is going to record every now and then. Number two, we'll talk about the calculus. Under the part of calculus, there are two types of calculus we'll discuss. One is differential calculus. And the second thing, we'll talk about integral calculus. And under the differential calculus, we have one more topic called maximum minima theorem, which is especially required in some numericals. It's not required every now and then, but still we have to do. It's very important for solving numericals or to understand in some of the chapters you'll get applications of the maximum minima theorem. And to some extent, we have the logarithm, number 3. We have binomial theorem. And number 5, we have series. Series of sine series, cosine series, exponential series, and all these formulas you have to remember. And the main topic that we are going to cover in this video is the basic trigonometry and the calculus, right? Under the calculus, we'll study the maximum minima theorem as well. The logarithm, binomial theorem are very specific things, and whenever it is required, we'll discuss on that topic concerned. So let us begin with the day with the basic trigonometry today. In this lecture, we are actually going to talk about basic trigonometry. Before I start everything, I'd like to tell you what the function is, because, in physics, not in physics, wherever we study, wherever formula we get, whatever physical equations we get, these are all dealt with functions. So what is the meaning of these functions? What does this function mean? For example, if I write a formula like volume of the sphere, V is equal to 4/3 pi r cubed. So that also comes under the functions. Here, in this formula that we have written, volume of the sphere, we have two types of variable, as you can see. We can have more than two types of variables as well. We have one V as variable and one we have R as variable, because whenever you are going to change the value of R, we have the different values of V as well, right? Now, here, as you can see here, the inputs, and we can have some outputs. So what are the inputs over here? The inputs are nothing but this R, right? And the outputs are nothing but this V, okay? So the inputs that we give different values of R, we can get the different values of output, that is the volume, okay? And the function is nothing but this rule. This is the rule by means of what? Here we are applying these functions to get the volume of the sphere. We can have different formulas also. For example, if I say the volume of a cube, that is V is equal to length, then this is L cube, the side cube. So here you change the value of the side and you get different volumes. So this is the rule. This rule is called as a function. Just like it's acting as a machine, we are giving some inputs and we're getting some outputs we have, right? Okay, so functions we express. So functions can be anything. It's just a formula, right? I just have said it's like a machine. So what kind of, it's a kind of formula, right? So this x square, as you can see here, we have taken an example. We are giving some inputs. We have taken just x square. We are giving some input x equals to 3. So we are getting the output as 9, right? So here y, the output that we can say, we usually express by the sign of y. Okay, so y is here a function of x. So y is depending on the x. Or we can also say this x, that is what we are saying, this x is our, independent variable. And this y is our dependent variable. Okay, we change the value of x, we get the different values of y. Now, we'll talk about different examples of the functions. Like we have a questions, just example that we have said earlier. We have the volume of the sphere v is equal to 4/3 pi r cube. So 4/3 pi r cube is the rule, right? This is how you are obtaining the volume of the sphere. So the volume of the ball of the radius 3 meter is what? So these are the value of x. This is the input that we are giving, independent variable, and this is the independent variable. It depends on the value of r. So if you put the value of x is equals to 3, so the volume you get it as 4/3 pi, and this is going to be 3 cube, that is 27. So we get 9, that is going to be 36 pi. Okay, 36 pi, and as per the unit, if this is meter given, so we have meter cube as our unit of volume. So this is how we understand the functions, because everywhere in the physics, in every chapter in the physics, we are going to deal with the functions. For example, if I write any formula of physics, like if I write, suppose the viscous force is written as 6 pi eta r v. Okay, so this force depends on the various factors. The force depends on the coefficient of viscosity, the force depends on the radius of the sphere, the radius of the object, the force depends on the, the velocity of the object. This is the formula we use in our viscous force whenever, suppose, for example, a spherical object is falling through some liquid. Okay, it experiences the upward dragging force. This is what we call as viscous force. This force depends on various factors, like its radius, like its volume, like its velocity, with what velocity it is falling through. This is actually called as terminal velocity, we'll discuss later on. And it depends on the coefficient of viscosity, eta, as well. Right? It changes liquid to liquid. So this force becomes here a kind of, dependent variable. It is the dependent and these are our independent variables. So here, folks, they can write the function force as a function of eta, r, and the velocity. So this is how we can express. And this is our rule. 6 pi eta r v is nothing but our rule by means of what we express the function. Okay, so now here we have given some couple of examples that you can pause the video and can try with. We have taken a function fx which is equals to x squared 3. Sometimes in general it is also written as y is equal to x squared plus 3, because we usually express y as our dependent variable and x is our independent variable. Now some couple of questions are given, like if not, you have to find out if 0, if 1, you have to find out if x squared. You just have to replace x as 0 and you can get your value. So if I put x equals to 0, I'll get it 3. If I put f equals to 1, then we get 1 square plus 3, which is 4. If I put f x square, then we get what? F of, this is going to be, I've just put it, yes, so it's going to be x square plus 3, so you get x to the power 4 plus 3. We have f of x plus 1. So f of x plus 1 means that instead of x, we are going to put it as x plus 1. So it's going to be x plus 1 whole square plus 3. Okay. And this means this last parameter that I have given to calculate, this is a function of 1. That means you have to perform it twice, right? So first you find function of 1. So we already have found out already. So f of 1, we get it as 4. So now function of 1. So we already have the function of 1 as 4. So now whenever we perform it again, so we have to basically find out f of 4. That is going to be 4 square plus 3, right? So it's going to be 19. So this is how we deal with the functions. Why I have said before I just have started the trigonometry, there is a reason. Because we deal with the functions everywhere. Whatever expressions we are writing, whatever physical formula you're writing, all are functions, right? Everywhere you are dealing with the functions. We are dealing with the variables, just all. Now coming to the topic of trigonometry, basic trigonometry, we are going to start with a very simple example. You can say it's kind of definitions. I'll start with some angles because this trigonometry idea, we are going to deal with the different angles in the trigonometry. So first of all, measurement of the angle and relationship between degrees and radian. This is what we are going to deal with first. We'll learn the formulas gradually. Okay. So first of all, what is an angle? Can anyone define what is an angle? So angle is not, everybody says that angle is the just intersection of the two different straight lines. So whatever it forms, its angle, maybe this side or this side. So this is not the actual definitions of angle. So angle is nothing but, you might have seen, you have drawn a circle here, right? And we have taken our arc length called AB, as you can see in the diagram. So this arc length AB also encompassed an angle of theta, right? With the center, it is encompassing an angle of theta, and R being the radius of this circle that we have taken in our exam. Now, we express that theta as arc length divided by radius, right? Arc length divided by radius. So, what is this theta? How we can express this theta then? If I take the radius as unity, that is of one magnitude, so theta becomes the arc length itself. So the angle is nothing but the arc length of a unit of a circle having the unit radius. This is how we define it. This is the actual definitions of the angle. So how we define the angle? Angle is the arc length of a circle having unit radius, right? This is how we define. Now coming to the next topic, as the relationship between the degrees and radian. How we can find out the relationship between degrees and radian? You already have come to know from your childhood classes, like pi radian is equal to 1/8 degree. But how it came actually? So the same formula I'm going to use, that is theta is equal to arc length by radius. Now, if I start my journey from A and if I return back to the same point again, if I just return back to the same point again after completing one complete circle. So what is my the total? This is the total circumference traveled. So what is the arc length? It's nothing but the 2 pi here, right? It's going to be 2 pi into r, that is the circumference traveled, divided by this radius, right? So theta becomes now how much angle, if I say in terms of angle in degree, so how much angle we have traveled if I start my journey from A and returns back to the same point again. So we travel, so we go by 360 degree angle, right? So it's going to be 360 degree. So we have, so this R and R gets cancelled. So from there we can understand this 360 degree becomes equal to 2 pi, right? So from there 180 degree that you have learned, that is pi. So this degree is equal to pi radian. This is how we define the relationship between the degrees and the radian. Now any degree you want to convert into the radian, so you can understand 1 degree is equal to pi by 180 radian. So any degree you have, if you want to convert the degree into radian, you just have to multiply it with pi by 180, that's all, right? You have already taken it separately. So if you want to convert the degrees to radian, you just have to multiply with pi by 180. And the radians to degree, just the reciprocal of it, that is 180 by pi, right? Okay. Acha. Here we have given some conversions just for an example. Here I have written 45 degrees to radian, so I can convert this 45 degree to radian. So I have to multiply with pi by 180, just we have said earlier, right? So it becomes 45 multiplied by pi by 180, which comes as pi by 4. So 45 degrees is equivalent to pi by 4 radian. We have opposite phenomena, we have in the radian, we have to convert in degree. So we multiply it by, so whatever we have, we multiplied it 180 divided by pi. We have to convert now into degree. It is pi gets cancelled, so we have 30 degree. That's all. There are some standard values of angles whose radian value you always have to remember for solving numericals. Okay, you don't have the time enough to convert every now and then, but you have to remember. In fact, for this is the reality. You have to remember these values. I have taken already. We'll give you this PDF after completion of the video. You can get it from the description box. Okay, the full annotated PDF wherever I am teaching this. So standard values, I have already taken the standard values. 30 degree is equal to pi by 6 radian. So for all of them, you have to remember 45 degree pi by 4, 60 degree pi by 3, 90 degree pi by 2, 120 degree 2 pi by 3. 120 degree is nothing but it is a multiply of, if I just multiply 60 into 2, that becomes 120. So it's 2 into pi by 3. 135 degree, so it's a multiply of 45 multiplied by 3. Okay, 3 times of 45 degrees. So for 45 pi by 4, so we have 3 pi by 4. These are very much standard values required every now and then. So that is why whatever I have written, that is up to 9. These 9 standard values you always have to remember, to quickly your numericals. We have 150 degree. 150 degree is nothing but the 5 times of 30 degree. So we have 5 pi by 6. We have 180 degree. We already have said pi. And for 360 degree, 2 pi, right? So this is what you have to remember always. Coming to the next topic in the basic trigonometry of our syllabus, that is the measurement of positive and negative angles. This minimum idea you should have, that where we take, which angles we take as positive and which angles we take negative, right? And we'll come to the quadrant rule little later. Okay, so here we have drawn the x and y axis. We have taken an angle with respect to the x-axis, horizontal axis. So whenever we measure the angle anti-clockwise directions from the x-axis, we take this as positive angle, and with respect to the x-axis, whenever we go in the same angle, if I go anti-clockwise directions, for example, if I go anti-clockwise directions, so that angle is going to be negative angle in that case. So in the clockwise directions, the measured angle is always negative angle. And in the anti-clockwise direction, the angle that we measure is called the positive angle. I hope you have understood by this. Now here are a couple of examples we have taken to understand we can measure the values of positive and negative angles. As you can see, we have started my angle taking from here. We have gone for a complete rotations, and then we have gone to this, right? We have gone in the anti-clockwise direction starting from the positive x-axis. So my angle is going to be definitely positive angle. So for a complete rotations, we come by 2 pi, and from 2 pi we have gone again by pi by 4, because this is our pi by 2. The angle between x and y axis is nothing but pi by 2. So half of this pi by 2, this is going to be pi by 4. So you get 2 pi plus pi by 4. So here we get 9 pi by 4. That is our positive angle. Similarly, here we have gone for a complete circle, that is 2 pi. And we have gone for another half semicircle, that is again pi. So 2 pi plus pi is going to be 3 pi. And that is also a positive angle because we have gone in the anti-clockwise directions with respect to x-axis. In the third example, as you can see, we have gone in the clockwise directions with respect to positive x-axis. So we have gone through one pi by 2, and we have gone again pi by 4. So it's going to be minus pi by 2 minus pi by 4. So we get minus 3 pi by 4. In the number 4 example, we are again going in the clockwise directions. We are going completely one circle. Then we have gone another pi by 2. So we have minus 2 pi minus pi by 2. So result is here minus 5 pi by 2. So this is how we measure the angles, the positive angles and the negative angles. So I hope you have got an idea that how to measure these positive angles and the negative angles, right? Coming to the next topic of the basic trigonometry. Now gradually, time to time, we are learning this one. some basic trigonometric ratios that you have started already in the class 9 and 10. But still, I just want to enlighten on these portions, the few small timing. This fixed basic trigonometric functions you have to study, right? So I hope everybody knows that. Some people have curly brown hair, that story. Okay, trigonometric ratios, sine, cosine, tan, sec, cosec, and cot, right? So sine, here we have represent, this is the right angle triangle. Okay, this is the right angle. This is the right angle. So opposite to the right angles, we have the maximum side. This is hypotenuse, or you can call it as this is hypotenuse, the maximum side. This is the opposite, the theta. We always take the side which is opposite to the theta, that is opposite or perpendicular. So opposite angle to theta, opposite side to theta. This is always your perpendicular. And we have adjacent, that is what we call as base, which is adjacent to theta. That is what we call as base technically, right? So I hope everybody knows that sine theta, cosine theta, how it is written. If you not know, you can remember always. Some people have curly brown hair, texture permanently black. So this is the rhyme you always remember from your class 10. So some people will underline the first letter of the word that you have written. Curly brown hair, texture permanently black. So some goes for sine theta. So here we have sine theta, that is equals to perpendicular by base. We have cosine of theta, which is base by, by mistake I have written base. This is hypotenuse. This is base by hypotenuse, and we have tangent of theta. I'm writing on myself actually. Tangent of theta becomes perpendicular divided by base. And we have cosec theta, sec theta, and cot theta, just the reciprocal of sine theta, cos theta, and tan theta. So everybody knows this actually. Now, a very important triangle we are going to discuss, very important right angle triangle we are going to discuss. You will get this triangle every now and then in various types of problems in your physics. Say in laws of motion, say in work energy power. In different cases, you get this triangle. This is a very important triangle in our physics actually. This is called 3, 4, 5 triangle. You always have to remember these 3, 4, 5 triangles. Right? This 3, 4, 5 triangle. As you can see, if I do, this is the side 3, this is the side 4, this is the side 5. It also comes under the Pythagoras theorem. If I write down root over of 3 square, if I write root over of 4 square, that is perpendicular plus base square, we get the hypotenuse, which is 5, right? So it's a right angle triangle. This is the right angle, right? Okay, if we consider now, the angle is very the triangle is very special. Why? Because the maximum side, that is the 5, whose opposite angle is 90 degree. And then we have gradually, if we come the decreasing order of the side, then we have the side 4, whose opposite angle is equals to 53 degree. And we have the least length side, that is 3, whose opposite angle is going to be, you can understand we have 180 minus 90 plus 53 degrees, so we have 37 degrees. So the angles are very important because you'll get questions of like which problem you have inclined plane problem. So in those problems, you'll get the angles like 53 degree, 37 degree. So you really need to know what their value actually is. So 37 degree, opposite side is 3. We have 53 degree, opposite side is 4. We have 90 degree, opposite side is 5. So from here, if I write, for example, sine 53 degrees, so its value is going to be perpendicular by base. So whenever we consider the angle, the opposite side, so we are considering this angle right now. So its opposite side is 4. So whenever I'm writing 53 degree, So 4 is acting as our perpendicular. So the perpendicular by hypotenuse, that is 4 divided by 5. Similarly, if I write sine of 37 degree. Now, whenever I'm talking about sine 37 degree, this is our angle. So its opposite side is 3. So perpendicular is now 3, right? Divided by 5. So you get 3 by 5. If I write cosine of 53 degree, for cosine of 53 degree, for 53 it is the perpendicular, so its adjacent is 3. So you get 3 by 5. And for cosine of 37 degree, we get 4 by 5. You can understand it's acting as a complementary angle as well. Whenever I express sine of 53 degree, I can express it as sine of 90 minus 53, right? Which comes under the cos 37, which is equal to 4 by 5, same guy. Okay? And whenever I write sine of 37 degree, it comes under 90 minus 37, which comes as cos 53. I'll talk about this thing later, that how we are finding out how we are changing from sine to cos and cos to sine. Right? Coming to the next topic of this chapter, basic trigonometry. Yes. The next topic is the rules to find, very important topic, rules to find out the trigonometric ratio of the angles greater than 90 degree. Right? So how we find out, we have given some examples. So with examples, we'll proceed. We have 2 examples, sine 120 degree and evaluate cos 135. We'll start with sine 120 degree, right? So step by step process you have to follow. You may sometimes pause the video to understand each and every step, and you can try it by yourself. If you know that, it's very fine. Let's get started. What are the steps to follow to calculate sine 120 degree? So the first step, you need to know the quadrant first of all. Actually, before I start telling everything, I have to tell you the quadrant. So what is that quadrant? So whenever we discuss quadrant, let me tell you, we have 4 quadrants, because whenever we plot, say I'm plotting graphically, let us understand this is positive x-axis, this is negative x-axis, this is y and negative y-axis, right? We start measuring the angles. I already have said in the concept of angles, we start measuring the angles anti-clockwise directions, taking the positive angles, right? So from the x to y, we have the first quadrant. First quadrant, we already go through 90 degree angle. So this is our first quadrant. And in the first quadrant, all trigonometric functions like sine, cos, tan, and everything is positive, right? All are positive. In the second quadrant, to the y to negative x-axis, this is our second quadrant. In the second quadrant, we have sine as positive. So here only sine theta is going to be positive. You can check it out in the calculator. So the second quadrant comes under to 90 degree. It's up to 90 degree. And then we have 180 degree, right? As we reach in the negative x-axis. So in between 90 to 180, whatever values you have for sine theta, these are going to be positive. And rest, the trigonometric functions are going to be negative. We can check it out. Suppose, for example, if you check sine 120, it's going to be positive. You can check it out in the calculator. We are going to find out the value soon. And if you check that from cos of 120 degree or tangent whatsoever, it's going to be negative. Coming to the third quadrant, this is called third quadrant, coming in the anti-clockwise direction. So in the third quadrant, starting from 180 degree to 270 degree. If I add one more 90, so we get 270. Okay. So this is here all sine. Here we have only tan theta as positive. So here only we get tan theta as positive. In between the values of 180 to 270 degree, whatever values of tan theta we have, this is the positive value. Apart from tan theta, like sine theta, cos theta, all are going to be negative. Coming to the last quadrant, this is called fourth quadrant. Fourth quadrant starting from 270 degree to 360 again, coming back to the 0 actually. Okay, so this is the fourth quadrant. In the fourth quadrant, we have only cosine theta positive. And the rest of the trigonometric functions are going to be negative. So all sine, tan, cos. This is what we call as ASTC rule, right? Starting anti-clockwise, ASTC rule. All sine, tan, cos, as per our quadrant respectively, right? So coming to the rules now, very important rules. So first of all, you have to express, we are starting with sine 120 degree. You have to express in sine If it is sine theta, it's fine. If it's cos theta, whatsoever is the function. So it's sine 120 degree. We have to express it as sine in pi by 2 plus minus theta. We can express either in plus theta or we can express in minus theta, no problem. So we'll show you both. For plus theta and minus theta, we'll go simultaneously so that you can understand both of the things, how they're happening. So if I express sine 120 degree in terms of plus theta in pi by 2, right? In pi, we always have, n can be anything starting from 1, 2, 3 and so on. So you always have to express it in the integer multiple of pi by 2 plus theta or minus theta. So from sine 120 degree, so we can express it as sine 90 plus 30 is 120, so we can write it as 1 into pi by 2 plus 30 degree, right? Or if you want to try with negative of theta, you can definitely try. I'm just like an underline to, express both of the things together. So I can also express it as sine of 2 pi by 2, which is going to be pi. And from there, if I subtract 60 degree, I'm going to get my 120 degree back. Okay, so sine of pi, 180 minus 60 is also sine 120. So both of the things, the result will come at after all is going to be same. Let's take the next step. What we have to do next? We have to check the quadrant. In what quadrant this value is lying? So sine 120 is lying in which quadrant? Between 90 degree to 180 degree. So it's the second quadrant, right? So it's second quadrant. So we have already checked the quadrant. It's the second quadrant. Now second quadrant, now we have to put the sign according to the quadrant, right? In the second quadrant, all sine, tan, cos. So second quadrant is the sines quadrant. So the sine theta is going to be positive. So we'll add the sign, that is plus. Okay. So we're now gradually obtaining the result. So we have plus. And the last, we have to express whether the n is even or odd, right? Whether the n is even or odd. Now, in this parameter, we can see our n is odd. And in this example, we have seen our n is even. Now, if n is, just make a note, if n even. So we have expressed it as sine of n pi by 2 plus minus theta whatsoever. So it's not going to change. It comes under sine theta. So sine of n pi by 2 plus minus theta, there is no change, right? No change if the n value is even number. Now, if the n is odd number, then what is going to happen? If your n is odd, then that sine of n pi by 2 plus minus theta, now its sign changes to complementary, that is cos. Now it becomes cos theta. If you have with cos, it turns into sine, right? So if n is odd, sine n pi by 2 plus minus theta changes to cos theta. So here, so we have 30 degree in pi by 2 plus 30 degree here. So it's odd. So it's going to be sine gets converted into cos. So it's going to be cosine of 30 degree. And here we have n as even. So we have n pi by 2 minus 60 degree. So n being even. So it's not going to be changed. So we have sine of how much? Theta, that is 60 degree. Both the values of cos 30 and sine 60 are same. Its value is root 3 by 2. Its value is also root 3 by 2. So this is how we find out the value whenever we have the theta greater than 120 degree. You can try this out, this example, cos 135 degree. Pause this video and try this. I hope that you have learned how to find out that value. It's required if the class 10 students are also watching the video. You can try this out. It's very important. It's going to be recorded every now and then in your physics. Okay. So check this out. Evaluate cos 135 degree. In any process, you can either express by plus theta, you can express by minus theta, whatever you prefer. We can try this. Pause this video and try this. Okay, so here we go with cos 135 degree. So it can be expressed as cosine of 1 into pi by 2 plus 45 degree, because you know that 45 plus 90 gives us 135. So here, first of all, I have to check the quadrant. So 135 degree comes under the second quadrant between 90 to 180 degree. So cos theta there is negative because it is the quadrant of sine. So you have to give the minus sign, and n being odd will change it cosine to sine, that becomes sine of 45 degree. So it becomes minus 1 by root 2. This is the value of cos 135 degree. I hope everybody has understood how to get this value. You can try the minus sign as well, minus theta as well. Right? Coming next, there are a couple of examples we have taken. Here we have taken an example of sine of 31 pi by 3. Pause this video and check this out. Calculate sine 31 pi by 3. Okay, so this 31 pi by 3, how we can express? We can express it as sine 10 pi plus pi by 3. So it's 30y plus pi, 31 pi by 3. We can express like this. So 10 pi, how we can express in terms of pi by 2, because our general format is with the integer multiple of pi by 2. We have done it earlier. So we can express it as sine 25 by 2. Can I do that? Plus we have pi by 3. Okay. So 10 pi. So we are rounding the circle 10 pi, right? So pi like this. So 5 times we can also write as 5 into 2 pi. So we have made a complete circle 5 times. Then we are going to we're going again by 5 by 3. So if I express in terms of quadrant, to ensure what quadrant it is lying. So 5 times 1, 2, 3, 4, and 5 times we are going back again to the same point in the x-axis. Then again from here pi by 3. So we are actually reaching to more 60 degree. This is the, for example, say pi by 3, 60 degree. So it's lying under the first quadrant. So this value is in the first quadrant, right? So in the first quadrant, in the sign value being positive, we'll write it positive. Okay, now you have to check whether n is even or odd. So it's an even number. So there is no change. So we get sine of pi by 3. So what is the value of sine pi by 3 sine 60 degree? That is going to be plus root 3 by 2. So it's the answer. If you have found out the answers, pretty fine. Coming to the next. Okay, so here we go with some trigonometric formulas that every now and then you have to remember these formulas. Better take a printout of these formulas and keep it in front of the study table. Or better, it will be better if you write down the formulas by your own and keep it in front of you. Okay, taking printout is not going to be a big deal. Better you write down the formula, you can remember with. So some formulas which is required every now and then in our trigonometry, in our while solving the problems in physics, while dealing with the physics, better to say. Reciprocal identities, right? This is what we know already, cot x, cosec x, and sec x. These are the reciprocal of tan x, sin x, and the cos x respectively. Coming to the Pythagorean identities number 2, under this Pythagorean identities, we'll get this PDF in the description box, so no worry. After watching this video, you can download it from the description box. We have sine square x plus cosine square x as 1. The formula, this is what you have to remember. Number 2, from here, sine square is equals to 1 minus cos square x, or cos square x equals to 1 minus sine square x. Number 2, 1 plus tan square is equals to sec square x, or sec square is minus tan square is equals to 1. That is what we can also remember. And number 3, we have 1 plus cot square x is equal to cosec square x. Okay, so this is Pythagorean identities. Coming to double angle identities, number 3. Coming to double angle identities, what formulas we have to study? Sine 2x. Sine 2x is what? Sine 2x is 2 sine x cos x. Right? Sine 2x record every now and then. Sine 2x is 2 sine x cos x. Or we can also express it as 2 tangent of x, 1 plus tan square x. So this is our first formula. Second, cos 2x, important, cos square x minus sine square x, or we can, these 3 formulas you actually have to remember. This cos square x minus sine square x, we can also express it as 2 cos square x minus 1, and we can also express it as 1 minus 2 sine square x. So we have a couple of examples on the basis of this formula later on. Or else we can remember 1 minus tan square x by 1 plus tan square x. Okay, so we have basically 4 formulas on cos square x. So we have this one, we have number 2 cos square x minus 1, we have 1 minus 2 sine square x, and 1 minus tan square x by 1 cos tan square x. Number 3, tan 2x, 2 tan x by 1 minus tan square x. Number 4, cot 2x, cot square x minus 1 divided by 2 cot x. Okay, the derivations is not really required while studying physics or while studying the basic trigonometry. You are definitely going to learn separately in your mathematics class. Okay, but here we are going to deal with only those topics which are very required in the application part is important for us, right? We are not going to deal with the math. We're going to deal with the applied maths here. So half angle identities, you just make it's very easy to remember half angle identities. If you remember all these formulas of double angle identities, just check this out. We have sine x by 2, right? We have sine x by 2 here. So sine x by 2 is what? From this one, if you remember sine of x, sine 2x, if I replace by sine of x, if I do 2x by 2, so we'll get it at 2 sine of x by 2 and cosine of x by 2, right? So sine x becomes 2 sine x by 2 and cos of x by 2. So this sine x by 2 is coming as plus minus 1 minus cos 2x by 2, cos x by 2, 1 plus minus 1 plus cos x by 2, and similarly tan x by 2 you also have to remember. Okay, coming to sum and difference identities. Sum and difference identities is required also in every now and then. Okay, sine of x plus minus y is sine x cos y plus minus cos x sine y, right? Sine, whenever we do plus, then we have plus. Whenever we do minus, we have minus. Cos of x plus minus y. In cos of x plus minus, we have minus plus. Just the difference. Whenever we do plus, we have minus. Whenever we have minus, we do the plus. And tan of x plus minus y is tan x plus minus tan y divided by 1 minus plus tan x tan y. These are the formulas you have to remember every now and then. We have some other formulas as well, like multiple angle formula. In the multiple angle formula, we have sine 3 theta as 3 sine theta minus 4 sine cube theta, cos 3 theta as 4 cos cube theta minus 3 cos theta, and tan 3 theta as 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Okay, so this multiple angle formula also you have to remember. Coming to sum to product, sine x plus sine y. These are the formulas you also have to go through. I'm not reading this formula by seeing this PDF. We'll directly come to the problems. Okay, you can check it out. You can get it from the internet. You can get it from my PDF as well. Okay, coming to some calculations directly. The formulas, how you're going to use the formula that we have seen in the formula tables, right? So whatever these 2 pages, if you go through these 2 pages and if you write down these 3 pages, this page, and this page. If you go through these 3 pages, whatever formulas are there, it's sufficient to learn. You can deal with all types of numericals in physics if you go through these 3 pages. Just write down all the formulas given in these 3 pages, keep it in front of your study table, that's all. Automatically, time to time, you can remember everything, right? First example we have given, find out the value of tan 15 dt. Pause this video and try this out, how we can get the value of tan 15 dt. Okay, so tan 15 degree, we can express it as tangent of 45 minus 30 degree. So in which formula it comes under? We have one formula, tangent of a minus b. Let me tell you here, tangent of x plus y or x minus y. So whenever we do x minus y, we have tan x minus tan y divided by 1 plus tan x tan y. So we can express in that manner. So we have x minus y format. So we can write it as tangent of 45 degree minus tangent of 30 degree divided by 1 plus tangent of 45 multiplied by tangent of 30 degree. Okay, you know the values, the standard values I always have told you in the previous pages. You have to remember 45 degree, 30 degrees values. So tan 45 is 1. So it is 1 minus 1 by root 3 divided by 1 plus 1 into 1 by root 3. So this is what we get, right? So we get root 3 minus 1 divided by root 3 plus 1. So this is our final answer. Root 3 minus 1 divided by root 3 plus 1. Root 3 gets cancelled out. Okay, great. Coming to the next example, this example say, prove that cos 9 degree minus sin 9 degree divided by cos 9 degree plus sin 9 degree is equal to tangent of 36 degree. How I can prove this? Very simple proof. We can go in the similar manner, tangent of 36. So tangent of 36 can be expressed, we'll start from the right hand side here. So tangent of 36 degree can be expressed as tangent of 45 minus 9, right? It comes tangent of 36. So again the formula tan A minus B, tan x minus y. So you get tan 45 minus tangent of 9 divided by 1 plus tan 45 into tangent of 9. So tan 45 becomes 1. So 1 minus tan theta, we can express it as sin theta by cos theta. So you can write it as sin 9 degree divided by cosine of 9 degree, all divided by 1 plus sin 9 by cosine of 9. So cosine of 9 gets LCM, so it gets cancelled out from denominator and numerator. So we get cosine of 9 minus sine of 9 divided by cosine of 9 plus sine of 9. So here we have proved the formula already. Whatever is there in the LHS, so it's proved. Okay, I hope everybody has understood this example. Coming to the next example, this example, sin x by 1 plus cos x is equal to tan x by 2, right? This is what you have to prove. Sin x by 1 plus cos x is equal to tangent of x by 2. How you can prove it? Very simple. Here we need the half angles also. You know of the formula. We'll start with the LHS here. Whenever we write sine of 2x, it's 2 sine x cos x. So from there, if I replace the angle by 2 divided by 2, so it becomes sine of x. So it's going to be 2 sine of x by 2 into cosine of x by 2. So I can write it as 2 sine x by 2 into cosine of x by 2, all divided by 1 plus cos x we have. Now you know the formula of cos 2x. So in the cos 2x can be written in terms of what? We have 1 plus cos x here. So you know the formula 2 cosine square x minus 1, because we have to write it as cos x plus 1. So I bring the 1 in the left side. So we have cosine of 2x plus 1 is equal to 2 cosine square x. So now if I replace x as x by 2, so we get how much? 1 minute. We have just made a mistake. We have written 2 by mistake. Yes, cos 2x plus 1 is equal to 2 cos square x. So if I replace x as x by 2, so we get cosine of x plus 1 is equal to 2 cosine square x by 2. So we have this value. We already have this. This is 2 cosine square x by 2. So this 2 and 2 gets cancelled. 1 cosine theta is also gets cancelled. So we have finally sine x by 2 divided by cosine of x by 2, which gives us tangent of x by 2. Lot of formula are there, lot of numericals are there. It's not possible to achieve the goal in one day, definitely. You may face it, even after seeing the video, you may face problems in solving numericals. So because there are a lot of types of approach, gradually learn everything, right? Just you have to keep practicing. Okay. We have one more examples, tangent of pi by 8. So which formula you're going to use here to get the value of tangent of pi by 8? You can try this out. I hope you have written the formulas, and if you have not written, I'm just showing it here. You can check this out, which formula is going to be required to get the value of tangent of pi by 8. You see, here the formula we know for tan 2x, right? 2 tan x minus 1 minus tan square x. So we're going to take this help of this formula. Okay, so we have tangent of what? Tangent of pi by 8. Okay. If I write it as, the formula was tan 2x, which is equal to 2 tan x divided by 1 minus tan square x, right? If I write it as tangent of 2 pi by 8, because my objective is to calculate tan pi by 8, tangent of 2 pi by 8 becomes tangent of pi by 4, which is known to us, right? This value is equal to 1, you know that, right? So that is equals to, again, write it as 2 tangent of pi by 8 divided by 1 minus tan square pi by 8. To solve it a little quickly, we can take the tan pi by 8 as x, and there will be a quadratic quadratic equations is going to come. So it's going to be 1 is equal to 2x divided by 1 minus x square. So we have 2x is equal to 1 minus x square, right? So we have x square, okay, minus 1 plus 2x, that is equals to 0. So you just have to solve it. There will be two values because it is a quadratic equation. So we can use Sridhar-Acharya, and using the Sridhar-Acharya formula that is also very important. You have to remember this formula every now and then. It's going to be required whenever we are going to deal with the quadratic formulas, right? Quadratic equations. So it's minus b plus minus. How you can get the value of x? There will be two values of x, 1 plus 1 minus. Minus b plus minus root over of b square minus 4ac divided by 2a. How we are writing this a, b and c? This is in the format of a x square plus bx plus c, right? This is the format. A x square plus bx plus c, that is equals to 0, right? A x square plus bx plus c. So we have c as minus 1, you have b as 2. So you can understand. So you can write it as, so minus b, this becomes minus of 2 plus minus root over of b square. This is 4 minus 4ac. So 4ac becomes plus, right? So 4 divided by, we have 2 into 1. So one value, this is 8, that is 2 root 2. We have root over of 8, right? We have 2 root 2. So one value we get it as minus 2 plus 2 root 2 divided by 2. Another value minus 2 minus we get 2 root 2 divided by 8. Now question is which one we are going to choose, right? We are going to take this value or we are going to take this value. Which we are going to take? Just pause this video and think it which value you are going to take. Because it is this value is definitely going to be negative because root is 1.41. If I multiply it with a 2, this value is going to be greater. Obviously, this value is going to be negative, right? And this value is a positive value. So this is a positive value. This is a negative value. Now we are looking for tangent of pi by 8. This x, right? This is the solution for x. X is nothing but the tangent of what? Pi by 8. Now tangent of pi by 8, this comes under the first quadrant. You can remember the quadrant rule again. It comes under the first quadrant. So in the first quadrant, all the trigonometric functions are positive. So we are definitely going to choose the positive value. This cannot be our answer. So positive value because it lies under the first quadrant. If it is lying in the different quadrant and this is not the quadrant for the tan, then definitely the negative answer we have to choose. But it is under the first quadrant, so our positive value is going to be taken. Okay, hope this video was helpful. Now you have to go through all the formulas that you haven't gone through in this PDF. All the ideas, concept of angles, concept of the 3, 4, 5 bullet triangles, that is very important, and the trigonometric ratios, okay, different formulas that we have shown over here. The quadrant rule, how to check the values which is having greater than 90 degree. The quadrant rule is pretty important. So go through this PDF, go through this video, This is what we need in our basic trigonometry in our class 11. Okay, I hope you have enjoyed this video. And the next video, we are going to talk about the calculus, the differential calculus and the integral calculus. Okay, thank you so much for watching. Stay tuned.